The last part of the test. 3 integers into the following boxes that have a mode of 2. Well, for it to be a mode of 2, we'd have to have 2 of them because there's 3 numbers. If we don't have 2 the same, there won't be a mode. And a mean of 5. And if there's 3 numbers and they have a mean of 5, it means they have to add up to 15. 15 divided by 3 will give 5. So 2 and 2 is 4, which would leave 11 in here. Now the next one, 5 integers into the following boxes. So we might have a few options here. We might do a little bit of rough work. So they have a mode of 4. So we have 5 boxes. Let's put 2 4s into them somewhere to have a mode of 4. A median of 4. So the 4 needs to be in the middle box somewhere. So that's definite. So if we have a mode of 4, we need either a 4 here or a 4 here. Maybe we'll get away with 2 of them. A range of 12, so this number minus this number, the big one minus the small one has to be 12, and a mean of 5. So there's 5 numbers. 5 by 5 is 25. So we already have 12 in there. 4 by 3 is 12. So can we fit a range of 12 in there? We need another 13. We can, yeah, we can put a, we need 12, we need another 13. So we can't actually have a range of 12 here, you can see, because to have a range of 12 I need a 13 and a 1, which would add up to 14. That's the minimum I can have to have a range. So that's going to give me 1 too many. So if I change this 4 to a number that's just 1 less, 3, I'm going to get them to add up to 25. And if this number was 2, this number would also have to be 2 to get them to add to 25, and the range would change. So I think this is the only combination possible. I'm just seeing that they say 5 integers. So actually, if we try 0 and 12 as the range, that might work too. With 2 4s. That's 8 and 12, 20 would leave 5 to give me 25. So that would work too, just with the, if we want to keep the right order. So just let's check here. A mode of 4, yes. A median of 4, yes. A mean of 5, they do add up to 25. And a range of 12, they have a range of 12. So this solution works too. Following is a substitution question. Your calculator will calculate it for you. If you just replace p with -7 and put it into your calculator properly, you would need to use a bracket for the -7 here squared. Plus 15. Doing it manually, 2 by -7 is -14, -1 is -15, and the bottom we have the square root of 49 plus 15, which is 64. So we get -15, not 18, -15 over 8, which is -1 7/8, which is 875 as a decimal. Factorize fully one of these 4 terms. I see a 15 and a 5, and they both have an f. So I'm going to take out 5f, which would leave h plus 3, or 3 plus h. And then the next bracket would have to be h plus 3, or 3 plus h. It has to be 2h to give 2h squared, minus 2h squared, and that gives -6h. So we have 5f and 2h, both multiplied by h plus 3, and this is how we write it to finish. Writing the following as a single fraction, we cross multiply 4 times 5 to create our common denominator, minus x times 2x plus 1 all over the denominator is multiplied, which is 4 times 2x plus 1. Simplifying this, we're going to get 20 minus 2x squared minus x all over. It could be 8x plus 4. I might leave them, might factorize. Actually, let me try. Let me leave it as 4 times 2x plus 1 for a second. So can we factorize the top? If we take a minus out and get 2x squared plus x minus 20, we're not changing the value of the top. We still have minus 2x squared minus x plus 20 over 4 times 2x plus 1. So let's just go to a little bit of rough work and see, can we factorize this? Quick way to see if it factorizes. Check b squared minus 4ac. If that works out evenly, it will factorize normally. B squared is 1 squared minus 4 by 2 by c, which is minus 20. We get 1 plus 160, 8/20. So the square root of 161 is not even, so I don't think this factorizes anymore. So question 12 on the sample paper was different than this, which we'll do next, but this is the question we gave you at Christmas. Work out the missing side. You can all recognize the answers 3 here. 5 squared minus 4 squared, using your knowledge of Pythagoras. Square root of 9, which is 3. The angle ACB, just measure it here, or mark it on the triangle, it's this one here. So because we have all the ratios, so if we can use any ratio, you decide what to use. I'm going to use tan. We'll call the angle C. We'll say the tan of the angle C is equal to O over A off to the side. Opposite is 4 over adjacent, which is 3. And you just type into your calculator the inverse tan of 4 over 3. And it will give you the size of the angle. And we were asked for it to correct to the nearest degree. It's 53.1 degrees, 53 degrees to the nearest degree. And then the last part of this trig bit was a ladder you were told was 3 meters long, and it's placed against the wall, 1.5 meters against the bottom of the wall. How high is the wall? So this is just Pythagoras again. The square root of 3 squared minus 1.5 squared, which is equal to 2.6 on a calculator, which is 260 centimeters. If I didn't round too early at 2.598, we'd still have 259.8 centimeters, which would round off as well to 260. This was the actual question 12 given. It gives the diagram of a function cos x. Now we have seen the cos of angles. We've seen the cos of 0 is equal to 1, which is here's 0. And here's 1. We've seen the sine of 30 is equal to a half, so we say that the cos of 60 is equal to a half, or 0.5. So these are the ones that we know about. So let's see the cos of 60. Does that equate with 0.5? You can see here that it does. So this is the graph, or the graph of a cos function. Now the first part there, you're asked to use your calculator to find the value of sine 60. We know from our knowledge this is equal to the cos of 30. And that's equal to 0.866 on a calculator. Let's check it here. The cos of 30. It does give 0.866, you can see up here. So what else is in here? Draw the graph of y is equal to sine x on the diagram above you using the same axes, scales and domain. Can't imagine this ever being asked at junior cert. We're told the sine of 0 is equal to 0 and the sine of 90 is equal to 1, and we actually have put a point already due to our knowledge. So the sine of 0, we'll change the colour and do it in red, is equal to 0. The sine of 90 is equal to 1, so it's up here. Sine of 90 is equal to 1. We also have the point, well, we know where they equal. We know they're equal at sine and cos of 45. They're equal. So actually, with these 3 points, we should, without fear, be able to do this question, even though it might seem like, how can we do this question? We've never practiced it. You will get a question in the junior cert that you haven't practiced. That's the nature of all maths exams at higher level. So let's just check one other thing on this graph. We know the sine of 30 is equal to 0.5, so let's just make sure it goes through that point. 30 and 0.5 is here, so we just kind of missed it, but that would be acceptable in an exam. But let's put that point in as well, make sure we get there, we go through there, and just to have it a little bit more accurate, that's how the graph of cos x looks. In the last part, because we've already done this, because of our knowledge of these things, use our graph to estimate the point of intersection. We know, because of our isosceles triangle, it doesn't matter whether it's a 1, a 1, or a 2 and a 2, that these are both going to be 45. So the sine and cos of 45 are the same. So this is root 2, they're both 1 over root 2. If these were 2 and 2, and this was going to be the square root of 8, you'd still get the same sine and cos ratio. You get 2 over root 8, which is 1 over root 2. So when x is equal to 45 degrees, we get 1 over root 2, which is 0.707 or 0.71. Question 13. The photograph on the right shows a house, and part of the roof of this house is shown here in the diagram below. So we're given loads of information. We've 2 triangles that we can see. We've 3 triangles, but we're told AB is perpendicular to DC, which is why we have these right angles here. And we have AD is 11.8 and DB is 2. We have the angle 20 in here, and we're asked to use trig to work out the value of x. So you can see in this triangle here we just have a value of 2 and a right angle, so we don't have enough information to find x. That's why h is in the other one. So we have 11.8 here and we have 20. So opposite and adjacent, we use tan. We say the tan of 20 is equal to opposite over adjacent. Just make sure you get them in the right order. H over 11.8. So on your calculator type in 11.8 tan 20 and you will get H. So H is equal to, I'll take 3 decimals, 4.2948295. This is in meters. So now I have this triangle here. I have x degrees. I have 4.295. I have 2. I have opposite and adjacent, so it's tan again. So the inverse tan of opposite over adjacent is equal to x degrees. So x is equal to 65.03, and we can see up here it's to the nearest whole number, 65 degrees. And finally, if you haven't lost the will to live, we have another Pythagoras question. You know exactly what you're going to do here once you see these sides in terms of x, the 2 straight sides squared and added together is equal to the diagonal squared. Once you set this up and multiply it out, you're going to be able to show there's only one value for x for which this triangle is right angled. X squared minus 4x twice plus 16 plus x squared minus 5x twice plus 25 has to be equal to x squared plus 4x twice plus 16. Multiplying these brackets out, if there's something the same on both sides with the same sign, you can cancel away. There should have been a squared there, it didn't appear. So what are we left with now? There's an 8x and a minus, so we can't cancel them. So let's just write down what we're left with. X squared minus 8x minus 10x plus 25, and bring across the other minus 8x, and we've left nothing there. So we now have x squared, and we have a 10, an 8, and an 8 minus 26x plus 25 is equal to 0. Factorizing this, it looks like x by x. It has to be a 25 and a 1, and they're both minus to give me a minus in the middle and a plus at the end. So x is either equal to 1 or 25. So let's see which one is correct. If x is equal to 1, we're going to get a 5, a minus 3. No, x can't be equal to 1. So 25 would be 29, 20, and 21, let's see, is 29 squared equal to 20 squared plus 21 squared. Now I know 29 squared is 841, 841, 59 short of 900, 20 and 39. So that is equal to 20 squared is 400 and 21 squared is 441. We know our squares. 841 equals 841. Therefore, x equals 25. Only one value. And that brings you to the end of your Christmas test. If you haven't got 100%, you need to watch this video, perfect the bits that you're not good at, and revise until you get better.